What's up, guys? Welcome back to another video. And in this video, we're going to look again at Excel, but we're going to look specifically at calculating our required egress stair width. Woo, there's a lot going on here. Okay, before we get into it, if at any point in this video you happen to learn something, which I hope you do, please, there's a lot going on here. Please demolish that like button. Also consider subscribing. Really helps me out quite a lot. Okay, few disclaimers before we get into this because there's a lot. And this in particular is an egress stair width spreadsheet. It's going to help you determine the required egress stair width that you need for your stairs in your building. This is primarily for commercial buildings. Here are all the disclaimers. Primarily for commercial buildings. It is for egress stairs. This has nothing to do with convenience stairs where these codes may not apply. The next disclaimer is obvious. Please do your own homework, your own code check, because I'm not doing it for you. This is just a really great go-by to give you an idea of what your stair width might be really quick based on your occupant load. Obviously, really easy stuff. And then from there, you obviously need to confirm it. That's kind of the point here. Another disclaimer, or just something to be aware of, this is IBC. We're looking at International Building Code 2018. Now, I know this is not the latest and greatest, but that is because most authorities having jurisdiction would not necessarily always be up to the latest codes. 2021. Obviously, that's coming pretty soon. We're going to see that more likely with more cities out there, but this is a safe bet. And honestly, there's not a huge difference, if at all any difference, between 2018 and 21. So you have nothing to worry about in that regard. So the final disclaimer is, because this has taken me a lot of time, I am going to charge for this on my website. If you do want to download the spreadsheet, that will be on my website for a small charge. If not, I do appreciate you at least watching this video. So, alrighty, getting into this, there's quite a lot. And so a lot of the things I want to go over are not necessarily all the specifics to the code, because we did do a deep dive into the code itself for figuring out what is required for egress stairs, because there is a lot. And you can see here, this is just a very simplified version, but in all honesty, this is a really great start, if not enough, to get you the baseline of egress stair widths that you need. Okay, so where do we want to start? Well, let's start with this big white box. And again, I'm labeling this here, obviously 2018 egress stair calculations, and then we have listed numbers 1 through 10. Actually, right here, there's number 10. And so we have, you can kind of look at it as the steps that you need to account for when really calculating the stair width, because there are a lot of steps. But in reality, we want to look at this as well as the spreadsheet and kind of fill it out all together. Before I do get into the spreadsheet itself, the numbers that these are, they're not affiliated to anything in the code in particular. I have ordered them this way just for this spreadsheet's purposes. So these numbers don't really tie back to anything in particular, but I do have all the code sections here that do apply to everything that number's talking about. But then, so all the numbers here that I have are going to equate to all of the numbers on this second row. So just know that if you're wondering where this might apply in some of the code, that, basically where do we get this information and why do we look here, or what are we filling out here, you can always refer to say, okay, number 4 is looking at determining the factor to help us calculate our actual stair width. So this is just a great go-by as to, when you're looking at and filling out the spreadsheet, where these in particular inputs are. And so those inputs, and basically everything you need to worry about, is going to be everything in gray. So there's not very many. Obviously, we have the number of levels, sprinkler, voice alarm, handrail projection that we'll get to in a minute, and then occupant load. And I have this header, in a sense, highlighted because this is going to be the calculating the occupant load for every level that you have in your entire project. In this case, maybe you have 1, maybe you have 5, maybe you have 20. It doesn't matter. This will all work the same. So in this case, what is the first thing I'm going to do? Well, let's just start here at the left, because that makes the most sense. Again, these numbers are not necessarily in order, so that's not a huge thing, but the order that we go through right now is probably a good order that you want to maintain whenever you're doing this yourself. So number of levels, 1. Well, obviously I've built this out to where there are a lot of formulas, of course, but if you have just one level, then we're not really worried about the stair width, because there really wouldn't be any. If I'm being honest, there's just one level and then that's it. There's no stairs as far as requirements. Now, the further disclaimers, this has nothing to do with mezzanines where there are stairs. This has nothing to do with levels below grade where you're exiting up. I was not going to make it that complicated. Now, there's a lot of different code, and I'm not worried about basements or egressing up to a certain level. This is basically taking your traditional approach of saying level 1 is my exit level, and I only have levels above that. So that's going to be the final disclaimer here. So number of levels. Well, let's not work with one level because that's really boring. We're done. All I'll have is my occupant load that will determine the number of exits. That's it. Which that's helpful, believe me, it is, but that's not everything. So let's go from number of levels from 1 to 3. Let's change this to 3. And as soon as I do that, we actually have these levels filling out here. And so this is just a basic array. It's going to fill out the number of levels that you have here. And so because I have 3, I need to actually input my occupant loads. We can come back to deal with the sprinkler alarm and all this information. So basically, how many occupants do I have? Well, let's just say 220 or 265. That's great. And then maybe 112 and 112 again. Okay, so really at this point, nothing has happened yet. Obviously we have no other information. The only information we have is the number of exits and the minimum required accessible means of egress that we need for level 1. That's fine, but that doesn't help us the rest of the way. So what's the final thing we need to do? And this is not in gray necessarily, but the final thing we need to do is take all the information that falls within all of these, and it's just a bunch of formulas. We can select them all and then drag this down the number of levels I have. In this case, I have 3. And then boom, look at this. This is a lot of information, and we're going to go through it pretty quickly. But with all of that done, I want to now go back to the left. And so basically, what are we doing? Well, we need to determine if our building is sprinkled. And if it is, do we have a sprinkler system? Then great. If not, and basically our only choices here are yes or no. And that's really important. It's a yes or no question. Same with the voice alarm system. And I want you to watch the factor because this goes directly into number 4. Calculating the width here, we could see what we have to take into account to determine the factor. And in this case, our factor is going to be 0.2 or 0.3. And that's going to be based on the sprinkler or voice alarm system. So let's go ahead and change this from yes to no and see how that impacts the factor. I can change this to no, and then all of a sudden I have 0.3. And then likewise, I can change the voice alarm from yes to no, and then that doesn't change because it requires both. I have to have sprinklers and a voice alarm for the factor to be 0.2. And that's just multiplying by my occupant load per level to get my stair width, all of that. So we can go yes, and it doesn't matter which one I put for yes. I need both of them to be yes if I want the factor to be 0.2. Easy stuff, and all of this ties into all of those numbers. You can obviously see that they do change very slightly, not a lot because we don't have a huge occupant load. That's just the way it is. And then finally, we need to look at this, and I put this on no. Basically, is the handrail projection greater than 4.5 inches? So if I were to explain that, this is a better explanation, and I have it baked in here. Again, this is a yes or no question. Do handrails project into the stair width greater than 4.5 inches, which is essentially 3 inches, handrail 3 inches off the wall, and then a typical 1.5 inch diameter handrail, that type of thing. And so if you have your handrails projecting farther than that, then you're going to have to calculate your stair width differently. And so where is that where are you taking that measurement from? Well, you're taking that measurement from the width calculation location. In this case, it is the total tread width. So because I don't have that extra projection, I can actually go and determine my width from the total area. Like you could place your foot on a tread. That's kind of the best example I could say. It has less to do with the handrails at that point because the projections are not an issue. But let's say for some reason off of a wall, off a guardrail or something, you have a handrail that projects a lot farther than 4.5 inches, or really any distance farther than 4.5 inches. Let's say 6 inches. So you have a handrail that projects 6 inches off of a wall into a stair. Well, at that point, there's red flags that go up, and simply by saying yes, that means that we have to take that width calculation between our handrails. And so, yeah, this is just one side or the other. If you have one that is projecting farther than 4.5 inches, then you're going to have to make sure that this entire width calculation, everything that we get in the rest of the spreadsheet, is taken between the handrails. And so that's just basically where you need to account for the stair width being, as opposed to just the overall tread width where you can stand. So I'm going to leave this at no, obviously, because in most cases you're going to keep this kind of as small and as tight as it needs to be, because it's just an egress stair. I mean, we're not looking to get fancy with this. Okay. The next thing we can do is, I'll go ahead and add a fourth level. We can do the exact same thing. I'm going to add level 4, put 4 here. 4 will appear. And then finally, I just need to give it an occupant load. Maybe this one's 300. Okay. And then I can take all of this, again, it does not matter. I can just take this row, drag this down, and all of a sudden I'm populated there. Great. Cool. So let's start moving down these columns and get an idea of what we're working with. Well, so obviously the levels and then the occupant load, we just put that in ourselves. We have the number of exits. Again, I'm not going to go through every single code item because there's a lot here. I have a previous video, but when it comes to the number of exits, that was not in the previous stair video, but this is kind of an overall exit requirement number per level, and that's just purely based on the occupant load. If I have less than 500 occupants, then 2 is fine. If I have between 500 and 1,000, then I need 3, and then over 1,000, I need 4. So let's see that in action. So let's just say, for example, I have level 3 here, and I have, let's say, 499 occupants. Nothing changes as far as the number of exits, but of course, everything down the line does, which we'll get to. But then the second I go to 500, again, nothing changes, but 501, boom, I have 3. And that also means I have to have the minimum required accessible means of egress it's always going to be in the just one less than the required number of exits. So in this case, I've got 2. I need at least 2. And that's more just like, hey, be aware of this. That does not factor in. I will say both of these do not factor into the actual stair width. They're just kind of there to help you to say, oh, I'm going to start to need this number. While this doesn't play directly into the stair width itself, like as far as a requirement, it does factor into how you're splitting that up between stairs, because above level 1, these are all going to be stairs. And for, I'll have 2 stairs and you'll have 3 stairs, all of this kind of thing. All right. And after a short commercial break, we are back, and I've made one little, couple tweaks here that might help make a bit of a difference. You'll see here that I have an actual number of exits, and on top of this, I went ahead and put in an example that even I have worked with before. This was just based on some hotel that I worked on previously, and so this is the true occupant load of that hotel. And we can go through this here in a second, but the actual number of exits is now here. So the thing I want to make you aware of is that the number of required exits is based on per level. Like it's pulling based on that occupant load per level, and that's it. That has nothing to do with how things are stacking and basically how many exits you have on one level versus the other. Whereas this column, actual number of exits, is more in tune with that, because here we can see I have 503 here, and in theory, I believe it was 411, and so you can see when I have a occupant load of 411 on level 5, I only need 2 stairs to go all the way down to level 1. That's pretty simple. It's under 500. But the second I go over 500, then I need those 3 exits. And the cool thing here is that while the number of exits doesn't update here per level, they do update in the actual number of exits that I will see. And basically this means, oh, suddenly I need 3 exits on level 5. Well, I'm going to have that stair continue, all 3 of them, continue all the way to the ground. So I need 3 on every level. That's really important. And of course, the minimum required accessible egress, whatever, that's all translated the same. Okay, so we have looked at, obviously, the total requirement for our stair width. That's kind of the total that we would need per level here. And then we have the required width per stair as if we were going to spread that out evenly. Generally speaking, that's what we will do. And you'll see in a moment why we do that. And then we have the actual required width per stair. And of course, this is going to be based on all this information. And obviously, we need a minimum of 44 inches. We can see here, number 6, this is going to take us down here. We need at least 48 inches. And obviously, why is that not 48? Well, it's not 48 because we have the 48 inches because we're sprinkled. That's cool. I don't need that 40 inches, basically, is what I'm saying. And then obviously the guardrails, we talked about that earlier, the handrails actually, the projection, if it's just basically telling us where we need to measure from. That has nothing to do with the required width necessarily. But so we have a minimum of 44 here. And that's because I am sprinklered, I have voice alarm, all that, and I'm good to go. And so that's going to be my minimum. Now, here is the altered column, and this column is, it simply says loss of one exit. And this is referring to number 8 here, and we can see that this says the distribution of width must be so that one stair can take at least 50% of the capacity of the full load of that level, 1005.5. I'd highly recommend you read it and read the commentary. It's going to help you out a lot. But basically what it says is that if we were to lose one stair, like one of these stairs just boom, it's gone, we still have all of those people on those associated levels. We have that. So we need to exit them. And so what's the best way we can do that? Well, the code requires that if we do lose one stair, that the capacity of the remaining stairs, and the best example here is the fact that on level 5 we have 3 stairs. Let's say we go from 3 stairs to 2 stairs. We need to make sure that the capacity of those 2 stairs will account for more than 50% of the occupant load. And so, yeah, those 2 stairs are going to be a bit stressed, but we can't have them so small. Let's say it's 1/3 and 1/3. Obviously, that'll work. If they're for some reason less than 1/3, a quarter, that would work. But if below that, then you're going to have some issues, which is exactly why we tend to space that out evenly. So we take this required stair width and we will say, okay, well, we need a minimum of 33.5 for these 3 stairs, which obviously we cannot have. We need at least a minimum of 44. So what we typically do is take that and then divide that out by the number of stairs, or multiply that by the number of stairs. So we'd have 3 that have a minimum of 44. And obviously they can take on a lot. Let's see how many they can take on actually. And if you look at the end, the very end is going to say, okay, well, that's the total capacity for all those stairs, but the total capacity per stair, this is just going to look at each one of these minimum required stairs basically evenly distributed and say, okay, well, based on that, how many can they hold? 220. Well, obviously 220 times 2, if we have 2 remaining, is going to be 440, and that is much less than the total capacity, that less than half of the total capacity, which would be 330. So 440 obviously being over 330, which is half of 660, we are fine. So we can fiddle with more of these numbers. If we make this one kind of giant, we can see here, yeah, we have this stair now being able to take on 867, which is the total, obviously. Basically, this is saying that if you see this, where the total here is equaling the total occupant load, well, that means that I'm over the minimum. So I need to make sure that I'm aware of that. So moving on from the loss of one exit, the actual required width, what does that really mean? Well, in this sense, it means that you can kind of take this as an example. It's really just going to be one stair. It's per stair, let's say that. And I'll even put per stair here because that seems to make the most sense. This is going to end up being per stair. Now, this is what this really means is that if we do look at what it's referring to, number 9, it's saying take the largest required width and apply to all levels below, 1005.6. What that is saying is that if I have to exit a bunch of people on one level, and that's the top level, well, I need to have the stair width required for that level, obviously, but because that is above level 1, obviously, I need to maintain that stair width all the way down, regardless of the occupant load on any other level. So what's a good way to do this? Well, let's make this 103, and then we can make this one, let's say, 750. And so all of a sudden we see, yeah, we need 3 exits all the way down, but we also need a certain amount of width all the way down. And so that is going to take the highest in this case. So I'm actually going to make 103 level 5 occupant load and then put 750 on level 4. We can see what happens. So obviously our required width here, 44, and then it goes up to 50 based on this 750 occupant load. But if I look at the actual required width column, I can see I only need the 44 between my 2 stairs from level 5 to level 4. But as soon as I get to level 4 with that increased occupant load, I do have an actual requirement of 50. And we can see it's obviously right here and right here. It's actually mainly pulling from this column here. So I've got the 50, but then you can see every level below that is also 50. And that's because this is an example, it's per stair. Remember that. So whichever stair, if for some reason you have not evenly distributed your stair width between all three stairs, obviously this will be per stair especially, but if you've evenly spaced them all the way on each level all the way down, then this will apply to all stairs. But just know that as soon as you get to a higher occupant load, every level below that has, of course, with the same continuous stair, you're going to have to maintain that width all the way down. So that's very, very important to have. And a lot of times you're going to see these numbers look the same. Nothing's wrong. Just kind of know that, you're hitting your minimums and it's evenly distributed. That's kind of the assumption here. So just be aware of that, because we want to try and do that if we can. And so moving on here, we have the total capacity per stair. And so again, we just said it, evenly distributed stairs. Each one of these numbers is going to be associated to the minimum required width, or like, let's say the actual required width of that stair. And basically, what is the capacity of that one stair? And then all we're going to see here is the total capacity of all stairs. So how many stairs are there on that level? And then what can they handle? And we get that total number. So if you see a number, so this 750 capacity of the stair happens to match the occupant load of that level, it's a red flag. But what I really want you to be aware of is that it's because we accounted for the occupant load being 750, our required stair width, evenly distributed, is based off that load exactly. Like that's the required stair width we need. And so what is the end result of basically the total capacity of all those stairs? It's going to equal exactly the occupant load. And so the main thing to be aware of, and not so much a red flag, but the main thing to be aware of is that if you see a required width above a minimum, then the occupant load is going to match the total capacity of the stairs. And what does that really mean again? That means that you're probably going to want to increase the stair width a bit, just because you don't want to reach that actual minimum. In this case, we are just accounting for the minimum. Of course, we are. This whole thing is, what is the actual width per stair? As in, like, what's the minimum required? Well, because this stair all these stairs can only take on this amount, we might want to boost up that stair width just a bit, to account for a little bit more, just to give us a little more leeway. That type of a thing. Now, we don't need to worry about that with other levels, because let's take level 3, for example, where we have 3 exits. They're all 44 inches minimum. And so we have 220 occupants per stair. And so times 3 equals 660. Now, if we were to lose one, if we're going back to, losing one stair, we would lose 220 occupants that we could handle. Basically, we're left with 440, and that's over half of 660 being 330. So we're fine in that regard, which is why we'd evenly space them out. So that's just a long and roundabout way of saying, obviously, if we have the minimums here, we're going to have generally plenty of stair width once we even this out. But if we are if we're going over the minimums at all as far as stair width, then you're going to probably want to boost it up just a little bit more beyond that to account for a few more occupants more than that we are specifically specifying. Okay, so I know this is a lot of information. We looked at a lot of different code items, and really there's a lot here. Again, the main thing to be aware of is that everything in gray is information you're going to have to fill out. You're obviously going to have to fill out all your occupant loads per level and then copy down all of the formulas. Very easy to do. Please don't get hung up on it being difficult, because I'm happy to answer any question you have in the comments. That's going to be all you really need to worry about as far as inputting information. I have restrictions on levels being greater than 0, things like that. So you shouldn't get into too much trouble in that regard. But I'm happy to answer anything you have questions about. Also, I, of course, am going to charge for this because it's taken so much time, and I think it's worth it. But the thing with that is, if I do end up updating this significantly, or if I come out with let's call it a better version, a more user-friendly, probably out of Power BI or something more visually appealing, easier to use, then if you do end up purchasing this, you're going to get an email with that update, and you're going to be able to get that for free, no problem. I'm not going to leave you hanging in that regard, so don't worry about that. But really, we looked at everything is stair width. And again, the final disclaimer here I will say is I am not a code specialist, and it may not be 100% perfect, but I can say this is a great go by that you can use as a start to give you an idea of what to expect from your required stair widths in your project. Primarily commercial, probably egress. Yeah, of course. But beyond that, this is going to be a good start. And that's what I rely on it for. You can come back and update things and make sure you're along the same way, but obviously make sure you're using the right code. This is 2018. We might update to 2021 later on, but this is a good place, good start for you. Obviously, check your code based on everything, amendments for your local amendments, anything like that. So again, just a go by. It's the final time I'll say it. So I really hope you enjoy this video. I know it was long and I know we looked at a lot, but it should give you a good starting point for your stairs. So if you happen to learn something, please demolish that like button. It really helps me out quite a lot. Also consider subscribing. That does as well. And if you have any questions, leave those in the comments. I will answer all of them. I will see you in the next video. Have a wonderful day and thank you very much for watching.